Here's section 7.3, exercise 30. And this is another one of these long ones where it's really three problems in one. So they tell us we have y equal 10 over x squared, y equals 0, x equals 1, and x equals 5. And that's a region, and so let's kind of figure out what that is. Well, 10 over x squared, I know, is doing something like that. Y equals 0, x-axis. X equals 1 is here. X equals 5 is there. And so then I can kind of pick these out. That's 10. And x equals 5, that's 10 over 25. So that reduces to what, 2/5 or 0.4. So this is 2/5 or 0.4. And for that height, but we're doing that region in there. And so, okay, and it says first, let's rotate around the x-axis. And what's it say? It says use the disk method or the shell method to find the volumes by result. Okay, so here, if I'm going to rotate this way, I really like the idea of just slicing up the x-axis because that will be nice and simple. I know what this function is, so I know what my radius is when I go around. So I think I really like the disk method for this. And so we have pi, then an integral from 1 to 5, and my radius is just the height, so 10 over x squared. So I have 10 over x squared squared, and then times my delta x. Okay, so this is pi. Well, actually, squaring that out, I get 100 pi. And this is the integral from 1 to 5 of x to the negative 4 dx. So this is equal to 100 pi times x to the negative 3 over negative 3. Remember to add 1. So this is x to the negative 3 over negative 3 from 1 to 5. And so this is equal to 100 pi. And we put the 5 in, and so I get negative 1 over 3 times 5 cubed, which is 125. And then minus a negative 1 over, well, 1 to the third is 1, so I just get negative 1/3 like that. And so this is 100 pi times 1/3, that's this one, positive 1/3, minus 1 over 3 times 125. So I can factor the 3 out of the bottom just to make my life a little easier. I've got 100 over 3 pi. And what I have left is 1 minus 1 over 125. So that's just 124 over 125. So I get 100 times 124 times pi over 3 times 125. Well, I can do a little reducing. 100 over 125, that's just 4/5, so I've got a 4 there. Now 3, unfortunately, that does not go into 124, so not much I'm going to do there. So I've got 4 times 124 and over 3 times 5, all times pi. So this looks to be 4 times 124 is 496 over 15 pi. Okay, 496 over 15 pi. Again, we can go check that to make sure we did okay. So here we have our pi times our integral, and that was from 1 up to 5, I think. And that was 10 divided by x squared. But I need to square that, so, oops, that was strange. Didn't expect that. Okay, and then squared. And dx. And that says 103.88. And what the heck did we have? We had 496 over 15 times pi. 496 pi oh, that's looking good, divided by 15. Yes, okay. So there we go, 496 pi divided by 15. And that is our answer to number 30A. So now we go to B. And in B, they say the y-axis. Well, let's refresh what we had here. We had this region here, so we had something that looked like this. That's 1, that's 5. This was y equal 10 over x squared. This is, so that's 10, and this lower one was, that was that, 2/5. Okay, now in this case, we're going around this way. And if I do a disk, I've got two issues that I don't like. One is that I would have to, cut it perpendicular to the y-axis like that. And I don't really like that. Well, actually, three issues. Another issue is that the whole thing changes as to what's going on right here. And so I would have one answer between 0 and 2/5, and another answer that I would have to add to it from 2/5 to 10. So that's another thing I don't like. And then finally, it's an outer disk minus an inner disk. So I just prefer not to deal with all that. And so if I go with the shell method, okay, I go parallel to the y-axis. And so that means I get to cut up the x-axis. My radius is just x. Okay, I don't have this in here, but it doesn't care because the radius is of the soup can. And so the soup can has a radius of x. That's great. And the height is just this y equal 10 over x squared. And so this is the integral from 1 to 5. I have my 2 pi multiplied by the radius. That's just x. And then times the height, and that was just 10 over x squared, and then dx. So I do have that right? 10 over x squared? Yes. And so I like this. This is a much easier thing for me to think about and set up. And then I get this pretty nice cancellation where this becomes 2 pi integral from 1 to 5 of 10 over x dx. So I'll just get a logarithm there, bring out the 10. So I have 20 pi times the natural log. Now, absolute value of x, but these are all positive. So just x from 1 to 5. And so this is 20 pi times the logarithm of 5, since the logarithm of 1 is 0. Okay, great. So we can check that answer. I'm pretty happy with our cancellation there, so we'll just try this with our, let's see, 2 pi times the integral, again from 1 to 5, and then times our 10 divided by x, and that is dx. And that says 101. Notice a slightly different answer. Let's see. And then we need to check our answer, which was, what, 200 pi times log of 5? I think it was 200. 200 pi times the logarithm of 5. And, no, 20 pi. It looked almost good. Okay, 20 pi. There we go. And same answer. Lovely. So part B looks good here. So that's great. Part C. C finally is the line y equal 10. Okay, so again, remember our picture is this thing kind of comes down from 10. So there's 10. There's 1. And goes over here to 5. And in the bottom of that was 2/5. So we want to rotate around this thing. This is a good question, right? So if I do disks, I get to go perpendicular to y equals 10. And, so I go like this. I have an outer disk and an inner disk here that I have to subtract then. But not too bad because I get to use my 10 over x squared. I get to go along the x-axis. And if I tried to use the shell method, the problem I see is, again, if I slice this way, I have to change what I'm doing here. I've got two different types of things going on here because the curves change, the top curves change if I'm slicing this way. So I really don't like that so much, so I think I am going to go with disk. And so I've got an outer disk which has a radius of 10. Okay, so that's the big R. And then the little r, in that case, is it's this distance, right? So that's 10 minus 10 over x squared. Oops, sorry about that. Oh, wrong thing. There we go. Getting quicker at this. There's my little r, and so I need to square each of those and do that subtraction. And again, sometimes I just do the big R and I just do it as a geometry problem, and sometimes I put it in the integral. This time I'll put it inside that integral. So we have our integral. Again, we're slicing this way, so we go from 1 to 5. So every single one of these, I ended up going with slicing the x-axis. So we've got our pi. These are disks, so I have my r, big R squared, so 10 squared, minus the little r squared, 10 minus 10 over x squared, squared, and then dx. Okay, now we have this integral, so I have pi 1 to 5, have my 100 there, minus. Squaring this, I get 100, so that's nice. Those are going to cancel. Then I get a minus. Now I get 10 times the 10 over x squared, and then times 2, so I get 200 over x squared, and then plus 100 over x to the 4th. And that's everything, dx. So this is equal to pi times the integral from 1 to 5. Now, 100 minus 100, that's 0. And then I have to remember my negative here. So I get 200 times x to the negative 2 and a minus 100 times x to the negative 4 dx. So this is pi. And remember to add, so I've got 200x to the negative 1 over negative 1, and then minus 100x to the negative 3 over negative 3, and that's from 1 to 5. Okay, putting the 5 in, so we've got pi. Now we start with the 5. We have 200, but that's a negative, so negative 200 over 5. And then now here's a minus and a minus, so now I have a plus 100 over 3 times x to the third, so 5 to the third, that's 125. Okay, so we have that. And then minus, we put in 1, so that's easy enough. That's a negative 200. And then again, a negative and a negative make a positive, so plus, and we put in 1, so we just get 100 over 3. So, a bunch of arithmetic, pi. Here, so we have a 200 from there, minus 200 over 5. And so I'm going to deal with that one. And then I have the 100, so plus 100 over 3 times 125. Oops, 125. And minus 100 over 3. So I can deal with, each of these separately. And I do this just because on the whole, I find students nowadays don't have very good computation skills. So, this is kind of how I do it. And, I get some things wrong, don't I? But, so this is 200 times 1 minus a fifth. So that's 200 times 4/5. And then plus, and I've got my 100 over 3. And I have 1 over 125 minus 1. So that's a negative 124 over 125. Okay, so it keeps going. This is pi. 200 divided by 5 is 40. So I get 160. And then I'll have a minus. And again, the 124 over 3, nothing happening there. But we do have the 100 over 125, which is 4/5. And so we get that same 496 over 15. Okay, and wow, that's ugly. And this is where, I would probably punt and say, oh, I don't want to deal with 160 and 4. So probably the way I'd handle this, other than a calculator, is 160 and go to a mixed fraction, because 15 into 49 goes 3 times with a 4 left over. So 46, that would be 3 more times, and 1/15. So that makes it a little bit easier. So I've got pi times 160 minus 33 and a 15th. Well, that's 160 minus 33 is 127. So it's 126 and 4/15. Okay, so unsatisfying, but that's what we have. And So we can check that. Again, let's look back at our integral. So we had this integral pi 1 to 5, 200x to the negative 2 minus 100x to the negative 4. Pi times my integral from 1 to 5, and that was 200 x to the negative 2, and then minus, I think it was, 100 x to the negative 4, and I need some parentheses, maybe. There we go. And a dx. Okay, I'll go back and check that while I also go check what we had for an answer. So, okay, so this is 200x to the negative 2, 100x to the negative 4. 200x to the negative 2, 100x to the negative 4 with the minus. Okay, that looks good. And then our answer, we're saying, is 126 and 4/15 times pi. So if I take 126 plus 4 divided by 15, and then multiply that by pi. Interesting. So those are really close. Boy, there's a good question. So did we get the right answer? But remember this, oh, what did I just do? I wonder if I can undo that. Whatever I just, oh no, I just moved it. This one here, this integral, it is a numerical integral, and we have this x to the negative 2 and, x to the negative 4. This is a tough one. I'm not really sure if what we are seeing is some round off. Now, decimals is usually pretty darn good, or did I have a numerical mistake? Well, let's check real quick for a numerical mistake. Okay, that didn't take me too long, but I did pause it while I looked real quick. Right, I did the 160 minus 33 and a 15th, and I said 4/15, right? But that's 1/15. That should have been 14/15. So that should have been what we did, and I checked that a couple different ways. I said, well, let's go back to the original, 160 minus the 33 minus the 1/15, and we do indeed get the 398.77. And here I did the 126 plus the 14 over 15 times pi, and that's the 398.77. So that was indeed wrong. Decimals comes through with a very nice numerical integration, and so there's our answer. And once again, we see I'm just not that good with numbers. And that, I guess, is all of exercise 30.